Welcome. I'm Steve French. I'm a principal software engineer with Azure Storage and working for Microsoft. I'm also a Linux kernel maintainer. I'd like to go through some of the exciting progress that we've made this year in accessing network files from Linux, whether that's on a local device, whether that's on some small embedded device or a large NAS server, whether that's on a Samba server or Windows, Mac, or in the cloud in Azure. It's been a very exciting year with contributions from many people. So Linus likes these humorous names. A year ago, we had the 5.7 kernel, Kleptomaniac Octopus. Now we have the 5.13 RC3, Frozen Wasteland. It's been a really interesting year, and I'm very happy for the progress we've made. Now, many of you guys who aren't familiar with file system activity may not be aware of the many things that are driving discussions in the file system mailing lists and driving the patch lists that are patches that are constantly being submitted in the Linux file system area. Some of that includes the rewrite of the FS cache. Dave Howells at Red Hat, as he considered rewriting this, also started working with Matthew Wilcox on a new interface for read-ahead logic, a new way to do read-ahead that was more powerful called NetFS, and that was able to leverage some of Matthew's work on Xarray. But these improvements to caching and getting rid of the read pages mechanism that's currently used in Linux has resulted in a lot of change. Also, there's been a lot of work, as you might expect, on containers and how to support that better, how to support the various namespaces that containers require. Now, we've had just yesterday, I believe, the QUIC protocol that's used for a lot of internet traffic is now an official RFC, and there's been discussions on, since SMB now supports QUIC as a transport underneath SMB3.1.1, how we could do that on Linux, not just on SMB, but how we could do this on other network file systems, which is a real challenge because there's no quick driver in the kernel as there is on some other operating systems. And then there's always questions about how to add additional information about files that are mounted and file systems that are mounted. There's file system specific data that can be used sometimes by more than one file system. Should that be exposed? Those kind of questions. And of course, there's been work on Verity and also on encryption in the file system layer for local file systems. And we always have this problem to deal with, that as storage goes from kind of a boring, similar speed disk drive to what the world we live in now, where storage can be 1,000 times faster depending on what type of device you choose. NVMe and now running over RDMA has created this possibility for extremely many orders of magnitude difference between slower and faster storage. We've also had a lot of improvements to Async Io. Samba, for example, is now implementing IOU ring, the new Async Io API, and takes advantage of the improvements in performance that can give them. And of course, we deal with the cloud. I work on Azure, right? So that can be very long latencies or very low latencies. And we also have to deal with files on multiple file systems coexisting and object and files coexisting. But I think it's extremely interesting in the world I live in with dealing with the cloud to just see the incredible difference in latency that you'll have between very, very high performance local virtual machines and sometimes quite remote. If you're at SNIA SDC trying to access a file in San Antonio, you could have much longer latencies than some of these high performance workloads, these HPC workloads. It's been a very interesting year, but these topics, are somewhat similar to what you saw last year, but the file system continues to evolve. Now, we haven't had an in-person Plugfest since a little over a year ago. So we are having a virtual Plugfest here for SMB, and I think that we're very fortunate to be able to have that. And so I'm looking forward to working with some of you guys during that virtual Plugfest as we continue to try to improve the implementations for various SMB's clients and servers. Now, what about the servers? There's another talk coming up later in the conference on the new kernel server, which is in Linux Next. Samba's fantastic. It's not going to completely replace it, but there are some use cases where the kernel server makes more sense. And it also ties in well with Samba. There are certain features of Samba that the kernel server can leverage and vice versa. So I think this is an exciting step forward for Linux to have an option for a kernel server. And selfishly, what it's helped a lot for us in the client is testing. It's allowed us to artificially create certain test cases that have been useful in finding bugs. And so I'm very excited about this progress, and I look forward to hearing more, listening to Namjae's talk on their current progress. So let's talk about the general file system world. The most active file systems are typically XFS and BTRFS. There are more than 60 file systems, but only a few of them, only 6 of them generate the vast majority of activity. The sys.ko that I maintain is the most active of the network or cluster file systems, and continues to it's ramped up a lot in the last 3 years. So over these last 3 years, this activity has been very broad from many companies, but it's been exciting, and these are some of the things I'll be talking about during this presentation. And also at the current pace, by the way, the SMB kernel server would be one of the most active components. It's getting a very large amount of activity, as you might expect, generating a lot of excitement as people find new features they want to add and bugs and cleanups. So a little more change detail. BTRFS was the most active last year with over 1,000 change sets. That's incredible. XFS continues to be extremely active, and it's the second most active file system. The VFS layer itself actually had its biggest year in activity, with many of these features that I described on the earlier chart being implemented. And the SMB client was the number 3 file system. Note that activity on NFS was down, as well as Ceph. But we are seeing a surprising uptick in NFS server activity, but it's still much less active than the kernel server and Samba. Samba, of course, is enormous, right? It has many, many features beyond a file server. So doing Linux file systems isn't always easy. Every year they add new syscalls. People think of Linux as POSIX, right? The Linux file system API is bigger than the whole POSIX API total. So just the file system is responsible for more than 200 syscalls. But we just added 4 last year. Here they are. Things like faccess@2 and close range, mount set attr. So file systems will continue to evolve, and file systems don't always have an easy job trying to keep up with this. But what's our goal? Our goal is to make sure that the SMB mounts behave very much like local mounts, so that all reasonable Linux and POSIX features, note that Linux is a lot more than POSIX, run fine on SMB mounts. We've got a long way to go. No file system implements all Linux features, all Linux file system features. But this is an incredibly exciting time as we try to ramp up the sets of features in the Linux SMB client, allowing us to make applications basically not have to special case running on a network file system. But we also have this job of, as Linux evolves, continuing to add these new features to the protocol, to the kernel client, to the servers. Now let's talk about some of the great progress recently. This has been a very good year for the CIFS client. Now, do you remember the security models we've talked about in the past? Basically, in the SMB world, we have 3 choices. We can rely on a default, that default mode, default owner, default group IDs. Those defaults make sense for most cases. You're already checking permissions on the server. Why worry about the mode? Why do the extra queries? But there's 2 other types of models that are important to remember, and they've made big improvements this year. One is the IDs from SID, mode from SID case. And that's often useful for a Linux-only case where the client's UIDs match. It allows preserving the UIDs and GIDs perfectly, opaquely in the ACL itself, similar to what the Windows NFS server did. And the mode bits preserved exactly. So the permission checks are as the client would expect, and the client can enforce the permission checks. That's similar to many NFS use cases. There's also a case where you're accessing the files from many different clients, Windows, Macs, Linux, and you want the modes to just be the best estimate, the best approximation for what the ACL is on the server. So in those cases, you can turn off permission checking on the client, report the mode back through the sys_acl mount parameter. And what that lets you do is the server is enforcing the permissions, but the client gets a good view of what the permissions are that's as accurate as reasonably possible. What this means, though, is that Windows clients, Mac clients, and Linux will all get similar behavior accessing the same files. So there are 4 parts to security. So what are the areas that we can improve security in, right? One is authentication. Now we've made good improvements to Kerberos mounts thanks to work by Sham and others. And we've got an enhancement to the NTLM SSP security that's in progress. We also have the permissions. What permissions do you have? There are 3 security models right now. We talked about the default one. We talked about the kind of the multi-user server enforced case, sys_acl, and the client enforced case where you have mode from SID and ID from SID. These are all greatly improved in the current and over this last year. So what else is there in the security world? We also have who you are. Being able to store. Typically, we've been able to retrieve the ownership from RFC 2307, from WinBind, from SSSD, querying an outside service to map the SIDs to a UID. But there are additional options now possible with IDs from SID, where we can store them sort of opaquely in the ACL, sort of as a one-off of the Linux local UID. Now, what about encryption? This past year, we added support for the strongest encryption type, GCM 256, and that's also very fast, by the way. And we're also excited because when Quick is added, we'll have even more choices for encryption. Windows Server already supports Quick, and the opportunity to give the user the choice of running over an encrypted Quick session or going over port 445 with GCM 128 or GCM 256 is very powerful. And don't forget that we also have the ability to manage access control and auditing. We've improved the CIFS utils to be able to query and set this information better through our tooling. Now, Aes Gcm 256 is now turned on by default. So it's the second choice. We offer GCM 128 first and GCM 256, then CCM 128. If the server prefers this, it can force negotiation now of GCM 256. If you on the client want to force it, set the module parm require GCM 256, and that will be the one that the only one that the client requests. So that's possibly helpful for some workloads that need very, very strong security. But I do want to remind you that AES GCM 128 is very fast and very secure. And many servers, for example, Azure, require encryption. So all mounts will be encrypted by default. So here's a trace of an AES GCM 256 mount, and you can see the cipher ID at the bottom. And you can see that it works quite well now. We've tested it to Azure, we've tested it to Windows. Now, multi-channel has been of interest to many people because multi-channel allows us to parallelize I/O much better. I wanted to thank Aurelian at SUSE for this huge amount of progress in multi-channel. It was originally added in 5.5 as experimental, but it was greatly improved in 5.8. And in 5.13, some important stability fixes were added for it, so it becomes more useful. And I think that it's definitely worth testing. The one area that we're still working on is when there's a reconnect, we will end up reconnecting the same channels, which is not always what you want. That's going to be fixed by the 5.14 kernel, but I think multi-channel has provided some really, really interesting perf data and is worth trying if you don't have the issue of the adapters on your server changing a lot. In some Windows use cases, for example, customers will remove and add adapters and expect the client to pick up these changes, and that's not supported yet in the Linux client. But multi-channel does offer very good improvement if the adapters are stable and you don't reconnect very often on the server. So let's talk about some performance improvements. Let's take a simple example. Just copy a large file. So in this example here, I'm copying a 10 gigabyte file from Azure down to a Linux client VM, just using DD in this example to make it simple. With the old defaults, it was 143 meg per second. If you run with SMB311, the newer default, goes up to 201 megabytes per second, which is 41% faster. But even just going to 2 channels, not even four channels, but even just going to 2 channels, using the new mount parameter RA size to control read ahead size. By default, RA size had been set to the read size, so in this case would have been 1 meg. Increasing the RA size with the new mount parameter causes it to be 3 times faster. So that copy of that 10 gig file now went at 450 megabytes per second, more than 3 times faster. So this is an example of some of the performance improvements. Multi-channel, RA size, SMB311. So how about another one? There was a really exciting change that went in recently, thanks to Rohith. Support for deferred close for handle leases. So this allows us to cache across close. So here's a really simple example of how this can help. So imagine creating a 2 gigabyte file and then reading it back. The read is 4 times faster. So what I did in this example was I did a DD, just put random data in a file, then I read it back. The reading it back part went from 3.7 gigabytes per second to 13.5. Now this is to Samba localhost, so it's going to be a little faster. But the percentage gain is going to be much higher for long latency networks. So you might get 10, 100, 1,000 times faster depending on how long your latencies are. But worst case, this localhost example, we got 3 times faster. That's more than 3 times faster. 4 times faster. So here's another example. Let's say you just read the same file twice. That second read is now 3 times faster. Once again, to localhost, the difference would be even greater if you were reading across the network. So being able to open a file, do some operations on it, close it, reopen the file, and keep it in the cache has helped. And we leverage an SMB feature called handle leases to be able to do that safely without any risk of corrupting data. So we've also improved debugging. So over the past year, we've added 10% more dynamic trace points. I think many of you are familiar with eBPF. The BPF tracing infrastructure, dynamic tracing, has been very helpful. And we have a large number of trace points to allow customers to do performance tuning and debugging, to help us as developers do debugging. And it's been invaluable. And I encourage you guys, if you have particular events that you need added to this for your workloads, let us know. Add patches, right? We can add more trace events. These don't have any performance impact when they're disabled, and they can be incredibly helpful in analyzing workloads when they're optionally enabled. So we added another feature called Shutdown. Shutdown allows you to force the file system to basically stop allowing new activity, preventing new open files. And you can see here the example after shutdown, we get an IO error. And also notice that with the support for the new mount API, we've added support for the new mount API. We can now do remount, changing parameters in many cases, but remount is much improved. But what we have here is we shut down, it stops the IO, it allows you to do a force on a mount if you want. Once you remount, the file system can be written to again. So here's a detailed list of the things we've added, 5.5 multi-channel, mode from SID, and 5.6. But I think what's been so exciting has been things like, and it may seem silly, but just being able, these small features like being able to set auditing information remotely, support for the witness protocol. So when a server moves, we're automatically notified. Some of these features that have been added last year have been very, very exciting. Now we support the cases much better when a server changes its IP address while we're connected to it. There have been some really neat performance boosts. We talked about RA size, but also all these sparse file improvements, fcollapse, finsert. We're also adding support for smaller fallocates in the future. So what do we expect in the future? We expect multi-channel reconnect improvements. We expect additional sparse file improvements, including fallocate file ranges, compression over SMB311, better POSIX emulation. And I think that what you're going to see as well is this move for some workloads to quick. Now that Quick is supported in Windows with SMB3.1.1, we'll probably start this by doing user space up calls to well-trusted modules like MS Quick, which seem to be tested well, and then move to a kernel module inside FSIFs. And then as we get more comfortable with the kernel module, that can be moved to a generic part of the kernel network tree. But this is a very exciting time because SMB3.1.1 over Quick doesn't only include things like improvements to encryption, more options for encryption, avoiding the port 445 problem where, for example, I can't save this presentation easily to Azure because the port is blocked by my cable provider. But it also, Quick provides improvements to congestion control and performance. So it may be useful for unencrypted cases as well in some cases in the future. We also need to add additional authentication options like PKU2U. But there are many, many small Linux features that we're also driving as we look at the various test cases. And thanks to the test cases we run in the build bot, we've had our most stable releases ever. We regularly run these regression tests, and it's been incredibly helpful. Anyway, I want to thank you guys for your time. The future is very bright here, and I welcome you guys to be testing at the SMB Plugfest that's going on now, and also in the fall at the main SNIA conference in. Hopefully we'll have that in person. We'll see. I don't know details on that yet, but it's a very exciting time for SMB, and I'm looking forward to more patches and more testing and more feedback from you all. Thank you for your time.